Hi friends, in this video I will write the Fourier series of odd and even function in the interval minus L to L. Now suppose f of x is a function defined in the interval minus L to L. Then we can write its Fourier series as a0 by 2 plus summation n varies from 1 to infinity an cos of n pi x by L plus summation n varies from 1 to infinity bn sine of n pi x by L. We can get the value of a0, an and bn by using Euler's formula. Now in this case, I will discuss two cases. One of the case, if fx is odd, what will happen to the values of a0, an and bn? Now we know a0 is given by 1 by L minus L to L fx dx. Now recall the concept of definite integral that we discussed in lower classes. If interval is minus L to L, fx dx, this is 2 times 0 to L fx dx if fx is even and its value is equal to 0 if fx is odd, if it is odd function. Now I have taken the case when fx is odd. If fx is odd, what will be the value of a0? 0. And what will be the value of an? We know an is 1 by L minus L to L fx cos of n pi x by L. Fx is given to be odd. What about cos x? If you remember, cos theta, this is your even function. Sin theta, this is our odd function. Fx is odd, cos x is even, product of odd and even is odd. This entire term is fx cos of n pi x by L is odd. Now look at the range of integral. It is varying from minus L to L. So by using this concept, I can directly write its integral as 0. Also, what about bn? Bn is 1 by L minus L to L f of x sine of n pi x by L dx. Now fx is odd, sin x is odd, product of odd and odd is even. So I can write it as 2 by L 0 to L fx sine of n pi x by L dx. Fine. Means if fx is odd and our interval is, pay attention, our interval should be minus L to L. We can use this concept only if our interval is of the type minus L to L. Fine. So bn, we have got the value of bn, we have got the value of a0 and an as 0. Therefore our Fourier series will reduce to summation n varies from 1 to infinity bn sine of n pi x by L, where Bn is given by 2 by L times 0 to L fx sine of n pi x by L dx. This is our first case. Case number 2. If fx is even, a naught, which is equal to 1 by L minus L to L fx dx, you can write it as 2 by L minus L to L fx dx. And an, which is equal to 1 by L minus L to L fx cos of n pi x by L dx. Fx is even, cos is even, product is even, so even I can write this as 2 by L 0 to L fx sine of n pi x by L dx. Now what will be the value of Bn? Bn, which is equal to 1 by L minus L to L fx sine of n pi x by L dx. Now fx is even, sine is odd, product is odd, so its result is 0. Therefore Fourier series in this case will reduce to a naught by 2 plus summation n varies from 1 to infinity an cos of n pi x by L, where a naught is given by 2 by L 0 to L fx dx, and an is given by 2 by L 0 to L fx cos of n pi x by L dx. Students, do remember this result is applicable if length of interval is in the form minus L to L. Now you can remember it like this: if interval is minus L to L, fx is our odd function, then which value? For odd function, a naught and an is 0. Even we can remember it. Fx is defined in the interval minus L to L. Fx is odd. Fx is, second case, Fx is even. If Fx is odd, which value is 0? A naught and an is 0. A naught is 0 and an is 0. If it is even, then Bn is equal to 0. This concept will be helpful while solving MCQ type questions. Fine. Now, question over here is how we can check whether your function is even function or odd function. If fx is the given function, what we will do replace x by minus x. If on replacing x by minus x, we are getting its result as f of x, I will say the given function is even function. Or if you will plot the graph of even function, I will give you the example. Y is equal to x square. If you will plot the graph of even function, y is equal to x square, it should be symmetrical about y-axis. Even function, if I write here, even function is symmetrical. This is symmetrical about y-axis. Similarly, if I ask you to check odd function, for odd function on replacing x by minus x, your result should be minus f of x. Then we say function is odd function. Or if graphically you will check, odd function should be symmetrical about origin. You can plot the example graph of y is equal to x. This is your odd function. Odd function is, if I write here symmetry, odd function is symmetrical. This is symmetrical about origin. Odd function is symmetrical about origin and even function is symmetrical about y-axis. I hope the concept is clear to you all. If it is clear, please like the video and subscribe the channel. Thank you.